All right, so in 6.1, we are classifying quadrilaterals, right? So we are, we've talked about different types of polygons. We know that in general, a quadrilateral is a four-sided figure. You can't see the TV, can you? Mm-hmm. Thanks. One of these days, I will remember. Yeah. Thank you. There we go. All right. So now we're going to get into like specific types of these because there's a lot of them. So just in general, some things we kind of need to remember. Right. So the sides that are like across from each other, those are known as and referred to as opposite sides. I would, because you would be surprised how often you all will forget that as we continue on. So, right, so if they're across from each other, they're opposite sides. So like the ones on the top and bottom would also be opposite sides. Then you also have, so if there's two sides that are like touching each other, so like this one and this one, those would be referred to as consecutive sides. Right, so like, I'm going to color them just to make it. Right, and so consecutive sides are like two sides, they come together and like form an angle. They're touching each other. Right, that makes them consecutive. Right, so they form an angle. I'm going to need two more. All right, so we also have opposite angles. Right, so again, those are angles that are across from each other, right? They don't touch the same sides. And then we also have consecutive angles. Right, so opposite just means they're not touching in any way. Consecutive means that they are, like, they have something in common. Or they form, like, they're touching each other. So does that make sense to everybody, what that means? Because these are, like, basically we're using these four things to, like, describe our quadrilaterals. Like, we're going to talk about if opposite sides are congruent or parallel or things like that. So we need to make sure we know what sides we're talking about when we say that. So the first definition we want to talk about for a quadrilateral is a parallelogram. So hold on a second. Is that big enough for you guys to read? Mm-hmm. Isaac? Okay. I'm asking you because you're in the back. So that is a quadrilateral with two pairs of parallel opposite sides. So what that looks like is, right, so we have this side parallel to this side, and then the top and bottom are also parallel to each other. So what does parallel mean? Right, well, they're going in the same direction, but it means that they would never intersect, right? Right, and so these little arrows, like on the pictures, mean that, like, they're parallel to each other. So, like, the ones with one arrow are parallel to each other, and then the ones with the two arrows are parallel to each other. So when you see that in a picture, that's what that means. All right, so that's a parallelogram. We also have a rectangle. Really? All right, so what's a rectangle?
Huh?
What's a rectangle?
It's basically a long square.
Essentially, yes. Right, but, so.
Two, congruent sides.
Parallelogram with 4 right angles.
Yeah, Kaylee read it out of the book. But yeah, so, right, think about a rectangle though. Again, it's got 2 pairs of parallel sides, but it also has 4 90-degree angles. So it's just a parallelogram with 4 right angles.
So pretty much it's like also.
We're going to like connect it all in a little bit. Yeah, so you're thinking along the right lines though. So basically with these definitions, they're all kind of like building on the previous one, right? So a rectangle has 4 right angles, but it also has all of the qualities we talked about of a parallelogram, right? So not only does it have 4 right angles, it has 2 pairs of opposite parallel sides. So I'm going to draw it in like a nice little chart for you guys at the end. It's just easier to do the definitions first and then put it all together. I drew like a big anchor chart of it somewhere. I need to find that and hang it up. I'll do that today. Or I might draw a new one. So again, rectangle, I guess I should draw that picture. That's a really bad rectangle. Actually, I'm gonna cheat a little. Rectangle. Look at that. That's okay, as long as it's a rectangle. So again, we've got the opposite parallel sides, just like before. Well, that's showing the parallel sides. And then we also have the right angles. Right. I'll fill that in. Oh. That's not what I wanted. It's fine. Okay, so questions about a rectangle. All right, so then next we have a rhombus. Oh, stupid autocorrect. There we go, not no bus. So rhombus is a parallelogram with 4 congruent sides. So since it's also a parallelogram, what does that mean? No. The sides are parallel, and they are congruent. Right, so congruent sides means the sides are all the same length. So like how the one up at the top is kind of like more long and skinny, this one's going to be more like a slanted square. Hey, no. Did you say curvy?
Like slanted.
Yeah, it's slanted, it's not curved.
Slanted square.
Curved would mean it would be rounded, which is not going to work for a polygon, right? Right, so again, we've got the parallel sides. I'm not drawing, I'll draw the triangles. So.
Can it be lines?
Well, yeah, so like the sides are parallel, we know that at this point. So then the congruent sides mean that like all 4 of these are congruent. And again, also the sides are parallel.
They're all congruent.
They're 4 congruent sides. For a rhombus, they are.
It doesn't look congruent on that.
Well, draw the little lines and say they're supposed to be congruent, and that's good enough. All right, then we're good. That's why we mark stuff congruent and don't just assume things are congruent because they look it.
Yeah.
Okay. So, questions about these 3 so far? I'm going to go to the next slide because I am out of room. Do we need a minute still? So, totally okay if we do. All right. So, next is, anybody have a guess? Square. So we can define a square in a couple different ways. So we can call it a rectangle with 4 congruent sides. Or we could also call it a rhombus with 4 right angles. All right, so the definition of the rectangle has the right angles in it already. And then the rhombus has the congruent sides. So a square has, it's got 2 pairs of opposite parallel sides. All 4 sides are congruent, and it has 4 right angles. So square. So again, we've got 4 right angles. We know the opposite sides are parallel, not all parallel, but they are parallel. And then they are also congruent. Right, so I'm sure you guys are all very familiar with a square at this point in your life. All right, so I'm going to move that up a bit just so I have room. All right, we have next is a kite. So this is where we kind of divert from everything's like some type of parallelogram, right? So a kite is different than a parallelogram. A kite's a quadrilateral with, I'm not typing, there we go. With 2 pairs of congruent consecutive sides.
Does it look like a kite?
Yes, it does. But the opposite sides are not congruent. So basically what that looks like, right? So it says 2 pairs of consecutive or congruent consecutive sides. So remember that the consecutive sides are like right beside each other. So we have like these 2, and then like these 2 down here are congruent to each other. So like this is congruent to this. This is congruent to this. But again, the ones across from each other can't be congruent to like themselves. So like the blue, like opposite are not congruent. So just the consecutive ones are. So yes, it actually looks like a kite, which is why it has that name. Right, for whatever reason, the kite is kind of a hard one for people to grasp. And then the very last one we have to talk about is a trapezoid. So a trapezoid is a quadrilateral with exactly 1 pair of parallel opposite sides. So only one side is parallel. So sometimes trapezoids look, right, they kind of look like, so they can be like this. Right, again, where our top and bottom are parallel, or sometimes they're even like this. Right, again, as long as you've only got 1 pair of parallel sides, both of those could look like a trapezoid. So like, I'm going to draw the, so again, those are parallel, those are parallel, right? The other sides cannot be parallel, right? Because notice it says exactly 1 pair of parallel. Because if both sets of sides are parallel, then it is parallelogram, right? So it's got exactly one pair of parallel opposite sides. Okay, so let's kind of, I want to take a minute and draw like the little like kind of flow chart we have going on here. So we know that kind of at the top we have parallelograms, right? Right, and so a parallelogram then gives us the definition of, right, rectangle. Right, so a rectangle is also a parallelogram. And what else did we define? Right, a rhombus. Right, and then we can say a square. Right, we can use both rhombus and rectangle to get to a square. So like with this, I kind of always draw my arrows like kind of backwards, just because it helps you remember that, like, so a square is technically a rectangle. It's also technically a rhombus, right? And a rectangle is also technically a parallelogram. But like going down the other way, like a parallelogram isn't necessarily a rectangle or a rhombus or things like that, because you don't know about the angles or the sides or things like that. And then kite and trapezoid just kind of like hang out here by themselves because they don't fit with anything. So, and normally like I do this and like put all the definitions and stuff in it. I'll try to print you guys a copy of it, but. So it is important to remember kind of how all of these are related to each other. It's going to be a big part of this chapter. Okay, just a couple other quick things in this section that we need to go over. It's a couple of theorems. Right, so if you look on page 250, Quadrilateral Angle Sum Theorem. And that just says the sum of the interior angle measures of any convex quadrilateral is 360 degrees. Yeah, you can write it on your theorem postulate sheet. It's okay if you want to just put it in your notes too. Look at that. I don't remember which one you're talking about, Kate.
Like angle side, angle congruent.
No. You were supposed to. I don't know that you guys actually did. It's okay. That's all right. I'm not that worried about it.
Okay.
So basically, this is just like the triangle angle sum theorem. So like all three angles in a triangle add to 180, but all four angles in a quadrilateral are going to add up to 360.
Is this the first one?
Yeah. Right, and so if you think about it, right, quadrilateral has four sides. No matter how, but no matter how you draw that, if you cut it in half, what do you have? Two triangles, right? So you have 180 plus 180, which gives you 360. right? So every quadrilateral you can split into 2 triangles, which is why that makes sense that they always add up to 360. All right, and then the next one that I want to go over there is the convex polygon angle sum theorem. So that's at the top of page 251. So that says the sum of the interior angle measures of any convex n-gon is n minus 2 times 180. So what that means is any polygon, right? So say it's a pentagon, it's a hexagon, however many sides it has, right? You can find the sum of the interior angle measures. So like angle 1, 2, 3, 4, 5. You can find out how many degrees those are all going to add up to by taking the number of sides, subtract 2, and multiply it by 180. So like for the pentagon, you would plug in 5. So it would be like 5 minus 2 times 180. So just however many sides it has, minus 2 times 180. So like 5 minus 2 is 3, right, times 180 gives you 540. So like in every pentagon, it's got the inside angles are going to add up to 540. Right, so like with the quadrilateral, so if we did 4 minus 2 is 2 times 180 is 360. So it's basically just a formula so you can figure out how many degrees are in different different polygons with different numbers of sides, which can come in handy sometimes. Right, so I'm going to circle that. Okay, what time is it? It's only 11:08. Okay, so that's going to really wrap up notes for today.